I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the section Complex Analysis that has appeared in the CSIR National Eligibility Test held on December 15, 2019. The question is related to the zeros of an analytic function. This question is placed in part C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 879801819. This question is suitable for all these examinations. Right. The given question is, let U be a subset of C, U be an open connected subset of C, and F is a map from U to C, which is a non-constant analytic function. Consider the following two sets. Capital X is equal to the set of all Z belongs to U such that F of Z is equal to 0. Capital Y is equal to the set of all Z belongs to U such that F vanishes on an open neighborhood of Z in U. Then, which of the following statements are true? We are given four options. Option 1, X is closed in U. Option 2, Y is closed in U. Option 3, X has empty interior. And option 4, Y is open in U. Agreed. Let's move to the next slide for a detailed solution of this problem. Right. Let's now discuss the solution of the problem in detail. We are given U is an open connected subset of U. Open connected subset of U. Given a non-constant analytic function F from U to C. Given X is equal to the set of all Z belongs to U such that F of Z is equal to 0. That means X is the set of zeros of F in U. Right. We call on options 1 and 3. Option 1, X is closed in U. Option 3, X has empty interior. It is known that the zeros of an analytic function are isolated when the function is not identically equal to 0. It is a non-constant function, means it is not identically equal to 0. Therefore, the zeros of an analytic function are isolated. That means they can be separated. Right. So, that is, if Z0 belongs to X and F of Z not equal to 0, then if Z0 belongs to X, Z0 is a member of capital X. That means F of Z0 is 0. Then F of Z not equal to 0 throughout some deleted neighborhood, 0 less than modulus of Z minus Z0 less than epsilon of Z0, since the elements of X are isolated. Why this can happen? Z0 belongs to X. That means F of Z0 is 0. Then then f of z is not 0 throughout in some deleted neighborhood of 0 less than modulus of z minus z naught less than epsilon of z naught. Why this happens? Because the elements of x are isolated, because they are separated. And because it is isolated, these elements are isolated, it has no limit points. It has no limit points. Because of this reason, we are able to find a deleted neighborhood in which there is no other 0, and at every point of this deleted neighborhood it vanishes. Thus it has no limit points. This happens because the elements of x are isolated. It has no limit points means that is the derived set, that is x prime, the set of all limit points of x is empty, right? So thus x is closed, since it contains all its limit points. Not only that, phi is closed. So phi is closed, therefore x prime is closed. Agreed. So the option 1 is true. Now, what about the interior of x? So let alpha belongs to x. Let alpha belongs to x. And that means alpha is a 0 of it. Then there exists an r greater than 0 such that the neighborhood of alpha with the radius r contains alpha and no other elements of x. It contains, because they are isolated, it contains only alpha, no other element of x. Why? Because the zeros are isolated, right? So thus we have found out a neighborhood of alpha with radius r which contains only alpha and no other element of x. Therefore, this neighborhood cannot be entirely contained in x. That means alpha is not an interior point. This neighborhood n alpha r is not entirely contained in x. Thus, alpha is not an interior point of x. So that means if alpha belongs to x, alpha is not an interior point of x. That means x has no interior points. So the interior of x is empty. Therefore, no point of x is an interior point of x. That is, x interior is empty. So the option 3, x has empty interior, correct? So option 3 is also true. Thus we have shown option 1 is true and option 3 is true. And we move to the next slide for the discussion of the remaining options. Right. We take capital Y. What is capital Y? The set of all z belongs to U such that f vanishes on an open neighborhood of z. F vanishes on an open neighborhood of z in U. Right. So we call on options 2 and option 4. Option 2 says Y is closed in U. Option 4 says Y is open in U. And we have Y, the set of all those z belongs to U such that f vanishes on an open neighborhood of z in U. Suppose beta belongs to f. Beta belongs to Y. Beta belongs to Y. This means there exists a delta neighborhood. There exists a delta neighborhood in which f vanishes at every point of this delta neighborhood. This implies there exists a delta greater than 0 such that f of z is equal to 0 for all z belongs to the delta neighborhood of beta because of the definition of Y. So that means, this means the delta neighborhood of beta is the set of zeros of fz. How many these will be? Because it is a delta neighborhood of beta, it is uncountable. It's uncountable. That is, the elements of n delta beta are not isolated. Why? Because it is uncountable. When it is uncountable, they are inseparable. But the elements of n delta are not, that is the elements of n delta of beta are not isolated because it is an uncountable set, which is a contradiction. That is, the zeros of fz are not isolated. A contradiction. Right. So, therefore, y is empty. Beta belongs to y, we got a contradiction, therefore, there are no elements in y. So, y is empty. And y is equal to empty is both open and closed. Therefore, option 2 is true and option 4 is also true. Right. Thus, all the options are true. The answer to this question, options 1, 2, 3 and 4. That is the detailed discussion of the solution of this problem. And it is definitely very interesting problem, and in a way it is an easy question also. I am sure that you have understood the solution of this problem. Thank you for watching the video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.